So on this example of the integral of sine cubed x all over cosine x, and that of course dx, I think trig identities because I'm looking at a bunch of trig functions in the integral here. And so when I start thinking of utilizing the trig identities, I start thinking of when I do my u substitution, what will some of the derivatives be? So we want to go back and remember our derivatives. So we have the derivative of our cosine x would equal negative sine x, and the derivative of our sine x would equal our positive cosine x. Another thing to think about is the fact that we have that cosine x in the denominator. So when I'm making my substitution, I'm trying to think of what's kind of inconveniencing me, and then also when I do my u sub, the derivative that comes out of it, whether it be the negative sign or cosine, depending on my u sub, what will be able to get used up here with the dx, and I'll show you what I mean when I separate this out. So I'm looking at that sine cubed x and going, okay, I need to get kind of a sine cosine thing going on here. So I'm going to separate out that sine cubed x to sine squared x times sine x all over cosine x, and that's dx. And now what I'm seeing here is, so if I were to let u equal sine of x, I'm going to end up with the cosine x, but the cosine x dx that I want can't happen because of that cosine x in the denominator. So I look at that cosine x in the denominator and say, okay, well, if I let u be cosine x, then I'll end up with a sine of x when I do the derivative, and then when I do my substitution, I'll have a sine of x dx that I can kind of get rid of there. But another thing to think about is if I'm going to make a u sub for cosine x, then I need to somehow transform the sine squared x to look like cosine x, because then my u sub could work all over on that left side. So I'm going to use my Pythagorean identity there, which will be 1 minus cosine squared x, and I'll leave the sine x, and then I have a cosine x in the denominator still, dx. Now I can look at that, and so I didn't show you all my messy work of trying u substitutions of what did or didn't work, but I explained my thought process of it. Now I'll go ahead and show what I ended up doing as a u sub after trial and error. So u equals cosine x, so du equals negative sine x dx, and that's something great. I love seeing that. So this here, now if I go ahead and I'm going to, don't forget about that negative sign there. So the negative I'll just bring all the way out front, and I have 1 minus u squared. The sine x dx just became du, and all over my u, because that's what cosine x is. And so remember with your fractions, a plus b all over c is equal to a over c plus b over c. So I could separate out that fraction there, and I'm going to put the negative all the way out front with a bracket, just so I remember the negatives there, and then I have the integral of 1 over u du minus the integral of u squared over u du. So I separated out so you could do that when it's plus or minus in the numerator and a single term in the denominator. And so I'm just going to work through some simplifying and taking antiderivatives. So that first integral will become natural log of absolute value of u. The second integral, notice u squared over u will just be equal to u, and so this will be minus u squared over 2. And close my bracket, and then I'm going to bring back in what my u was, which is the cosine x, so I get negative natural log of absolute value of cosine x minus, and I'm going to keep the brackets on that negative on the outside. I'll deal with, well, I could bring it in now. So that negative natural log absolute value of cosine x, and so the minus that was already in the expression, that's going to be a plus because these two minus the negative on the outside and the minus on the inside. So this will be cosine squared x all over 2, and then of course the plus c. And then there's my answer for this one.